Hi everyone, this video we are going to look at simplifying by the use of factoring. What simplifying means is, it means we try to write it in the simplest possible form. So it's kind of like editing, right? You can say the same thing directly or you can say it in like 3 sentences. But if you can get the point across in like 3 words, then you prefer that one. So essentially what it says is, when you see something like this, try and factor out. So this top here, this factors out. You can check. You need a product of 3. So that's only 1, 3, which add up to 4. So the top is x plus 1 times x plus 3 divided by x plus 1. Consequently, x plus 1 cancels out. So this complicated looking rational function is actually just the linear function x plus 3. And this is why the process of simplification is important, particularly as we move on and we learn how to combine rational functions. It becomes essential that we report the final expression in the simplest possible form. Similarly, over here, the roots are 2 and 5. So this becomes an x plus 2 times an x plus 5 over x plus 2, which again cancels out. And once again, this complicated looking thing is just a line. It comes down to being x plus 5. Right? Just another way to view this factoring is the x squared, and you have 4 x's and 3. So you stack 3 of them here, 1 here, and exactly 3 here. All right, this third one here, let's look at it a little more carefully, because now we still want to factor, right? But we have seen that sometimes these complicated looking things, they can be factored into something simpler. So this top one here, I'm going to try to split the middle term for this one, which means I'm looking for a product of negative 45 and a sum of 12. There's a lot of factors here to go through, but one possible combination is 15 and negative 3. They add up to 12 and their product is negative 45. So this means I can write this as 15xy minus 3xy minus 15y squared. Now from the list of the general strategies, because this is a trinomial, that is why we are going with the split the middle term. And then we use grouping. So 3x gives me x plus 5y minus 3y gives me x plus 5y, which comes out to 3x minus 3y and then x plus 5y for the numerator. Whereas for the denominator, it's only 2 terms, so it's more straightforward because it's 6x and then x squared minus y squared, and that becomes x minus y and x plus y using difference of squares. Right. Now here notice in the first term, the 3x and the 3y, they can be factored slight bit more just by using the greatest common factor, which is 3. So the numerator is actually 3 times x minus y and then x plus 5y, and the denominator is 6x times x minus y and x plus y. So in this case, the only things that cancel out are x minus y and 3 factors into 6 2 times. So it doesn't get simplified all the way like the previous 2 examples, but still what you have as a result of this simplification is a much simpler form than what we started with. right? So for example, there's no more xy terms. All of that is gone. It's simply x plus 5y divided by 2 times x plus y. All right. So this is going to appear again and again because now we're going to move ahead and do some algebra with these functions. So multiplication of rational expressions. What you want to do is write each numerator and denominator in a factored form. Okay, what that means is write it down as a product of its factors. And then when you do that, cancel out whatever can be cancelled out. So let's do that. So right here I have 5x plus 5 over 7x minus 7x squared and a trinomial, and then another thing here. So let's work on them one at a time. Now this is pretty simple. This just factors as 5 times x plus 1. The second numerator requires us to do a little bit of work, but we can still use our trinomial factoring to say this is going to be minus 2x plus 3x minus 3, or 2x x minus 1, which becomes 2x plus 3 times x minus 1. So, well, that's my first numerator, that's my second numerator. And I do the same thing for the denominators. I can factor out a 7x, and that's 1 minus x. Now this here, again, we're going to observe that 4 is 2 squared and 9 is 3 squared, which means that it's sort of hinting towards being a difference of squares. So this is 2x squared minus 3 squared, which then becomes 2x minus 3 and 2x plus 3. Okay, now that everything is factored and written in the simplest possible form, we rewrite the whole thing. So the whole thing becomes 5 times x plus 1 times 2x plus 3 times x minus 1 divided by all the denominator terms, which is 7x times 1 minus x times 2x minus 3 times 2x plus 3. And then we cancel out what can be cancelled out. So 2x plus 3, 2x plus 3. Now, x minus 1 and 1 minus x, this is a factor of negative 1. So this whole thing simplifies to negative 5 times x plus 1 divided by 7x times 2x minus 3. Okay, so that is what this is going to simplify to. So that is multiplication of rational expressions. The next is dividing rational expressions, which is very much similar to multiplication. Why? Because what is division, right? 7 over 8. That's actually 7 times 1 over 8, right? So division is multiplying by the reciprocal. Which means when we say divide this by this, right, if I write it symbolically, then it means divide x squared minus 5x plus 6 over x squared minus 3x, which is basically keeping the first term as it is. The reciprocal of the second term is just a fraction flipped. And when you flip this fraction, that's what it becomes. So now it's reduced to a multiplication problem, which means we can go ahead and factor our numerators. So this one is straightforward. It's x times x minus 3. This one, not so straightforward, but x squared plus 5x minus 2x minus 10, x times x plus 5 minus 2 times x plus 5, x minus 2 times x plus 5. So those are our numerators. This is already, this is already factored. This one here, I can go x squared minus 6x plus x plus 6, x minus 6. That is incorrect. The splitting should be, because I need the product to be positive, it's 2x minus 3x plus 6, x times x minus 2 minus 3 times x minus 2, which becomes x minus 2 times x minus 3. Therefore, the whole thing now becomes x times x minus 3 times x minus 2 times x plus 5 over 2x times x minus 2 times x minus 3. And then things can be cancelled out. So x minus 3 cancels out, x cancels out. And you're left with your simplified version, which is x minus 2 times x plus, I forgot to cancel x minus 2. So it's actually even better, meaning we have even fewer terms. So it is just x plus 5 over 2. So in fact, this whole division ends up becoming a linear function. Okay, so those were some examples. The important tool is factoring. Once you factor, the only difference in multiplication division is that for division, you need to flip the second fraction before you start cancelling out. That's it for this video. Next, we're going to talk about other operations like addition and subtraction. Thank you.